Welcome everybody. My name is Sebastiano Di Filippo. I'm Senior Director of Business Development at Qualcomm Europe. And today I'm here to talk about digital transformation in manufacturing. 5G is a very important technology that will help revolutionize Industry 4.0 in manufacturing. This slide I'm sharing right now is a good tool for me to explain level of maturity of the 5G technology in 2021. 5G technology was launched commercially in 2019, and to date, more than 60 countries have live 5G network worldwide, and more than 140 operators, mobile operators, have deployed 5G technology. And in 2021, we expect more than 500 million handsets to be launched with 5G technology. And with 5G technology, we refer to both sub-6 gigahertz and the millimeter wave technology. You can see in dark blue all the networks that are in the process of supporting 5G sub-6 gigahertz and millimeter wave as well. While operators are deploying 5G technology, 3GPP is standardizing the future releases of the 5G technology. Every release is adding more capabilities and more characteristics and features. And with more characteristics and features, the technology world is embracing more use cases, more verticals, with the objective to use 5G for many more applications. Release 15 of 5G was specified in the 2019 and was mainly meant for consumer applications, smartphones, tablets, and computers as well, FWA, fixed wireless access. The release 5G 15 of the 5G technology is also meant to start expanding the footprint of 5G to some IoT application. That is why there are already today commercial devices based on Qualcomm chip supporting release 15 for some initial Industry 4.0 use cases. But the technology is evolving. Release 16 has had in 2020 more characteristics and capabilities to a 5G system. URLLC and TSN for industrial IoT are in essence support of low latency and high reliability, as well as time synchronous networks for communication between wireless 5G system and the wired industrial system. Beyond that, even new radio in unlicensed spectrum is one way to expand the footprint of new architecture in the factory, where new spectrum can be used for 5G systems. Positioning is another very important pillar of the release 16, where 5G network's ability to identify and localize objects in the factory domain is really opening up to new application and use cases. Besides that, even 5G V2X side link multicast technology has been introduced in release 16, as well as eMTC and narrowband IoT for massive IoT and massive network of sensors. From release 17 onward, there will be a long-term expansion with many more use cases, capabilities, and features that will be added in the standard, 5G standard, for things such as new radio with low complexity, what is called the new radio light. There is a way for the semiconductor industry and the communication industry to scale to many more use cases with lower cost device and implement everything connected to 5G. But also XR and what is called boundless extended reality is something that new capabilities of future 5G releases will enable with the new technologies and new characteristics. And also expansion of the application field for positioning will be possible from release 17 onward, with the accuracy of positioning system in a 5G network to improve. Every industrial revolution is bringing some level of innovation, new technologies and new capabilities. Industry 4.0 really leverages connectivity in order to disrupt and implement many new level of efficiencies and the performance. 5G is a very important element of this strategy, the main one, as 5G allows new level of mobile connectivity, which is the building block of the factory reconfiguration concept, with very high level of security and with a very high level of compute integration, where the network is no longer only a 5G or a connectivity network, but is a intelligent network with fast communication and reliable low latency communication, bringing intelligence anywhere in the factory domain every time you need low latency, low reaction time, intelligent engines to take decision to control the entire network. So 5G is the enabler for new architecture to be integrated in a factory to really exploit new level of efficiencies. Some studies are indicating that 5G technology will unleash the power of the digital economy. There are some numbers that some studies such as the IHS Market One indicates in the range of $13 trillion as the potential, the power, and the potential in goods and services that will be sold by 2035 and will be enabled by the digital economy itself. 5G is a key component of this revolution and of this digital economy, and we believe that 5G will really boost a lot the possibilities of expansion of use cases and application in many new verticals and segments, spanning from the factory of the future to autonomous transportation, to the healthcare with remote healthcare, even precision agriculture is a very important development of the evolution of 5G technology applied to IoT ecosystem. Smart energy, smart utilities, and smart grids are another front where 5G technology will help to make much more efficient the production of energy, reducing dependencies on carbon and fossil sources of energy. Private networks for logistics, enterprise, and industrial IoT are already in deployment, but we see them as an area of acceleration of new architectures for ports, for airports, for factories, in order to really enable new use cases in those domains. Smart city are equally important, and they can really benefit from the adoption of 5G technology. The last one I would like to mention is digitized logistics and retail. So in retail, a lot of intelligence is required in order to build intelligent checkout systems, in order to build new logistics systems, and to raise the bar and improve to new level of efficiencies. In all these applications, there is a huge potential, but I would like to focus mainly on two applications. The first one of which is the flexible manufacturing. Flexible manufacturing or Industry 4.0 manufacturing will require the adoption of the 5G technology to implement new use cases, to spread intelligence in the factory, to take more decisions in a secure way, in a reliable way, leveraging a huge set of data, but also allowing the intelligence to take control of tasks such as predictive maintenance and process management, as well as control. Some of the new engines, devices in the factory that will communicate through a 5G private network and through a 5G network in general will be smart Ultra HD cameras, that will build a sort of visual intelligence with artificial intelligence and camera vision. A lot of sensors that will build the environmental sensing engine, the environmental sensing intelligence for the factory. AGVs, moving parts, robots, robotic arms. With wireless and mobility, many more objects and robots will move in the factory to reduce dependencies on the human factor, while the human being will still be focused on controlling and interacting with the automatic environment. But level of efficiency can really be improved with all those machines. So AGVs, robots, even new tools for the factory workers, such as new human-machine interfaces and display, no longer connected via wired cables, but wireless devices that factory workers can bring anywhere, interacting with much more freedom with the factory floor. This is one example of the new devices and new architecture in the factories. Another important use case is the smart warehouse. Enabling smarter warehouse is one of the ambitions of new 5G systems. Even in warehouses, the need for more intelligence, more tracking capability, more moving objects and devices in support of the warehouse workers is one of the major objectives of a 5G system. So many more UHD cameras communicating via 5G network for surveillance and for camera vision and intelligence, visual intelligence. Many more robots and AGVs for placing objects, for picking up objects, items, goods, assets, and ability to build sensors everywhere in shelves, in containers, ability to track assets and boxes, and to speed up the process, the logistic process in the warehouse by means of tracking devices much more efficiently and with more accuracy, is one of the major achievements that through a 5G system will be possible. One of the new frontiers of the Industry 4.0 through 5G technology will be also the use of millimeter wave. Millimeter wave can boost level of performance of a 5G system in order to achieve even more. I would like to give you some examples of what a 5G millimeter wave, which we are testing and assessing as we speak in the factories, which are the benefits that such a system can bring. For example, with the more communication pipe, still in a low latency domain, an AGV can, for example, multiply number of Ultra HD cameras in the moving device to augment the level of intelligence, surveillance, and efficiency of building a digital model of the environment for much more complex use cases, such as issues identification, surveillance of the factory or the warehouse, and ultra low latency and reliable control. Other use cases are in the domain of XR handsets and extended reality, what we call boundless extended reality. Some of those advanced tasks are, for example, next generation human-machine interface, remote guided maintenance and repair by factory workers, training experience. Always connected laptop and devices will also pop up in the factory floor, allowing and helping factory workers and people in general to interact more with the cloud, with the edge cloud, but also with the surrounding machines and devices in real time. Millimeter wave will help accelerate all those extreme capabilities and the use cases for the Industry 4.0. Millimeter wave technology can help expand the possibilities and use cases of Industry 4.0 even further by supporting many more technology options for the factory of the future. We have tests set up in manufacturing floors with more than 3,000 square meters and very high ceiling, where we deploy 5G millimeter wave networks operating in 28 gigahertz in NSA mode. And we observe very good coverage with very high average throughput, both in downlink and uplink. In throughput, in some of the tests we conducted, we have more than 1.5 gigabit per second in downlink and more than 120 megabit per second in uplink on average. For some of the new use cases, this is more than enough. For example, we could have new AGVs operating in the production, in the factory floor, doing automatic inspection in the production lines with overhead transmission implemented as well. Or we could have a remote augmented reality for equipment troubleshooting, for maintenance and repair. Or we can even have immersive virtual augmented reality for visitor in an education center or for training to the factory workers. Another very important pillar of the success of Industry 4.0 in the implementation of factory of the future, as we said so far, are private networks. They are not new. There are already deployments ongoing as per the public information in this slide, with many big industrial companies, automotive companies in Europe, in other regions as well, deploying private networks for Industry 4.0. Qualcomm is working very closely also with the 5G ACIA Alliance for Connected Industries and Automation, that is driving on the driving seat in connecting the industrial world and the telecom and wireless world in specifying requirements and collaborating with both industries in order to accelerate the adoption of the 5G technology for industrial IoT. The 5G technology has been designed to meet industrial IoT requirements. On one end, the requirements from the industrial world for Industry 4.0 are to support dedicated and reliable networks that are optimized for local services, to do it by using a wireless technology that is scalable and future-proof, and to add new capabilities such as the use of wireless industrial network. The way through which the 5G technology support this vision and those requirements is by enabling support of 5G private networks, as we discussed so far, but also to expand the support for new spectrum. So not only licensed spectrum or local spectrum, but also shared spectrum and the use of unlicensed spectrum that will be included and that have been included in the Release 16 of the 5G standard. Then ultra reliability and low latency, URLLC. Release 16 is enhancing capabilities of 5G to support URLLC that will be evolved even further in future to connect the two low latency words, the wired one and the wireless one. TSN is another very important building block of this digital wireless vision and Industry 4.0 vision. TSN, there is about supporting time-sensitive networking, will allow 5G wireless system to interconnect and collaborate with wired 5G networks with the low latency support. Last one I want to mention is positioning. Positioning will allow a 5G network to track devices, to identify localized devices, to really leverage a single connectivity fabric and connectivity network as the sole layer embedding all the 5G and the industrial use cases. One example of new use cases, beside the one we mentioned already, that 5G can enable that are not possible in old technologies, is well described in this slide. So we have cloud. Cloud is well known for as a container with a big capacity of data, but it cannot offer low latency. So latency is not predictable in the cloud. So the edge cloud on-prem in the factory or in the warehouse can implement a very capable storage level, but with a lot of artificial intelligence and the low latency communicating with the devices and the object in the warehouse or in the factory or in the campus via 5G network. In this case, we have edge cloud doing AI computation for building and rendering a photorealistic environment to be sent back to the XR headset. What is important in this process is the ability to have the XR headset to support on-device processing to complement the compute and the artificial intelligence and the processing in the edge cloud itself. With this mechanism, we can have almost a real-time interaction between very capable edge cloud and on-device compute and intelligence in order to build a photorealistic extended reality. Another example, the architecture in the factory will evolve, having still the cloud as a very important pillar of this vision for big data and analytics, but through a firewall also to separate the cloud from the local AI and edge cloud for sensitive data that can be stored on premises without sharing in the public domain the data that are very sensitive. And also in a very capable edge cloud, the local storage and the local compute engines can implement very low latency artificial intelligence tasks, interacting through a 5G network with the devices, with gateways, with actuators, with robots, with robotic arms, with cameras, and with the HMIs. So the four ingredients of this end-to-end architecture that will unleash the power of the new digital economy and the new manufacturing will be, of course, the big data analytics in the cloud, but the edge cloud with AI, the 5G infrastructure, and new devices and new use cases implemented in the factory. So we believe that with 5G technology and with new features such as TSN, URLLC, private network, low latency, positioning, and new spectrum, for the first time, we have the opportunity to support new characteristics, new features, new capability in the factory, such as wireless industrial Ethernet. And this will be one important way to disrupt and revolutionize the industrial domain, supporting flexible manufacturing and supporting productivity increase. Thank you very much.